Right, so part two of that first section, we're looking at multiples of whole numbers and, of course, throwing in some word problems now. So to create multiples of a number, we multiply the number by the natural numbers. So things like 1, 2, 3, numbers such as that. So multiples of 10 would be 20, 30, 40, etc. So our least common multiple of two or more numbers is the lowest number that is divisible by each of those two numbers. So if we look at 30 and 40, we're going to do this with prime factorization. So I set it up like I do before, 30 and 40. This time they're both along the same thing. And I'm again making my list of prime numbers that I am going to be drawing from as I go through. So first I see 2. They are both divisible by 2. So 30 divided by 2 is 15. 40 divided by 2 is 20. All right, so the next one that they are both divisible by is 5. So 5 divided by 5 is 3. And 20 divided by 5 is 4. All right, so that is the same steps as finding the GCF. If I were to find the GCF, I'll just do this off to the side as review. That would be 2 times 5, which is of course 10. So that would be my greatest common factor of these two numbers. But for the LCM, it's 2 times 5. But also here, notice how I'm drawing an L. I'm circling that L. So my LCM, lowest common multiple, would be 2 times 5, but then times what is left as well. So times 3 times 4. So my lowest common multiple of these would be 120. So that means that 120 is divisible by both 30 and 40. All right, so that's when we have 2. When we have 3 or more, there is a bit of a special case that's happening. So you set it up exactly the same. So 15, 32, and 44. So looking at this though, you'll notice that there isn't a common prime number for all 3 of them. But if I have 3 or more, my prime factor only has to divide 2 of the numbers. My third one is just going to continue going down. So in these numbers, I can see 32 and 44 are both divisible by 2. So I'm still going to use this 2. I'm just going to keep dragging that 15 down. Let's see, 32 divided by 2, 16. 44 divided by 2, 22. Okay, so I can again divide both of these last 2 by 2. The 15 keeps getting dragged down. 8 and 11. All right, so there are no more common prime numbers here. So my LCM, I make this L. So my lowest common multiple would be 2 times 2 times 15 times 8 times 11. And we put that into our calculators. And we'd get 5,280. All right, so that is the lowest common multiple of those 3 numbers. All right, and this last example here, 18, 20, and 30. Exact same process as we've been doing, setting them all up together and prime factors that divide into at least 2 of them. So here I can look at 2. So that will give me 9, 10, and 15. Okay, now in my next row, there's no common one for all 3, but I have 9 and 15, and those are both divisible by 3. So I have 9 divided by 3 is 3. The 10 I drag down, and the 15 becomes 5. And now there is, there is a common prime, and it is 5. 10 and 5 are both divisible. So see how I can switch back and forth with which ones I'm dividing them by? It just needs to be 2 of them. Let's see, now I can divide 10 by 5. So I'll be left with 2 and 5 by 5, I'm left with 1. So my LCM, you circle the numbers on the outside, and your bottom row. You're making a big capital L there. So my LCM be 2 times 3 times 5 times 3 times 2 times 1. And I put that into my calculator, and my lowest common multiple is 180. And so that's how we solve lowest common multiple problems. So we've got a few word problems here. So we are tiling. So this first one, what is the side length of the smallest square that could be tiled with rectangles that measure 16 centimeters by 40 centimeters? Assume the rectangles cannot be cut. So I need a square. I've got like a square room, and I'm going to be tiling, and I want these tiles to fit perfectly in each dimension here. I can't cut my tiles at all, so I'm looking for a smallest square that the 16 and 40 is going to fit into. So smallest and least. So this is my least common multiple that I'm looking for. My LCM of 16 and 40. So here we go, prime factoring. I'm going to divide both by 2. That's my lowest prime number. So 16 divided by 2 is 8. 40 divided by 2 is 20. Now again, both of these I can divide by 2. So I get 4 and 10. And one more time, I can divide them by 2, and I'll get 4 divided by 2 is 2. 10 divided by 2 is 5. All right, so my lowest common multiple, I'm grabbing the L. So my LCM is going to be 2 times 2 times 2 times 2 times 5. And we put that into our calculator, and I get 80. So the side length of the smallest square is going to be 80 centimeters for my side length. All right, so I'm looking for a small square, so I'm using my least common multiple. This next example, I'm looking for the largest square that I could use as a tile. Right, so I have now a rectangular room, and I need, square tiles that are going to fit in here perfectly. So I have a large square tile, so I'm looking for my GCF, my greatest common factor. Now I already did the prime factoring steps up above here, so my GCF is just these ones along the outside. So my GCF would be 2 cubed, which is 8. So the largest square tile has a side length of 8 meters. 8 meters, 8 centimeters maybe, but 8. 8 would have to be my side length for this square in order to fit in both of them. All right, so that is some word problems. Again, if you see something asking for the largest, something that goes inside a largest tile, that is going to be the greatest common factor. And above here, a small square room would be a least common multiple. All right, and that is it for this little section. So just lowest common multiples and identifying if you're finding GCFs or LCMs from a word problem.